Yes, we now have the session.
Start and to share the slides, presentations. Just a moment. Okay, so now we start into the first session of MMSys, which is about advances in delay-sensitive media. We have the questions on Slido, and I will bring up that very soon. But we have 4 papers for about 30 minutes right now. Each speaker should now try to enable video and audio. If someone can try to unmute them, and we will have a short pitch for all the presentations. And in order to not waste too much time on that, so the first one will be presented by Mohammed Haq from University of Helsinki, and he will briefly introduce the paper, The Bits of Silence, Redundant Traffic in Voice over IP.
Hi. Thank you. Thanks for the introduction. I'm going to briefly discuss about this paper, The Bits of Silence, Redundant Traffic in VoIP. Our human conversations said less or among more two or more speakers are characterized by brief pauses during the conversations and the so-called this turn-taking behavior among the participants. And the duration of such events may vary from a few hundred milliseconds to seconds. Besides, these conversations may take place at different ambient noise setup. In the context of VoIP, this means that there are frequent periods where this microphone only captures silence or background noise. This can result in processing and communication overhead, as these packets actually do not carry useful information. In this measurement study, we investigate the performance of popular VoIP applications on our smartphones and the corresponding speech codecs in suppressing silence in different noise contexts. We introduce a reproducible acoustic, traffic, and energy measurement setup, and we demonstrate that a particular codec do not provide the optimal performance in different conversation contexts. Therefore, we believe that context-aware codec negotiation prior call setup can benefit the device, network, and user.
Thank you very much, Mohammed. The next is in line from Said Shafi Sabet from Simulamed in Oslo, and he is also affiliated, I think, with the Quality and Usability Lab at TU Berlin. Is about a latency compensation technique based on game characteristics to mitigate the influence of delay on cloud gaming quality of experience.
Hello, everyone. Thank you, Christian. In this paper, we propose a latency compensation technique to improve the gaming quality of experience when there is delay. The technique is proposed especially for the cloud gaming, as the latency is one of the major challenges for the cloud gaming. The idea is to change some game characteristics and reduce the delay sensitivity of the game so gamers can perform better under delay, and as a result, their gaming experience would increase. We identify 5 characteristics, and we implement these characteristics in 4 games. And then we conduct a subjective study using crowdsourcing. The results shows the lag compensation technique can significantly increase the gaming quality of experience. We also analyze each of these 5 characteristics, and we found that some of these characteristics are more effective than the others. I encourage you to watch the full presentation, and please ask your questions in a slide.
Okay, thank you, Said, for the nice introduction. The next one is from Mariam Amri from University of Ottawa, but she finished already her PhD, now working in industry, but yes, in this area of networking. And she's presenting a paper on resource optimization through hierarchical SDN-enabled inter-data center network for cloud gaming.
Yes. Hi, everyone. As the main challenge with cloud gaming is the latency and delay, our work focuses on these challenges and how we can somehow mitigate that. There are different approaches to mitigate the latency and delay in the cloud gaming. Most of the work focuses on the video processing part, but this work is focused on the network part. And we focus on the efficient central resource management for multiple distributed data center, which each data center using the software-defined networking. We present a novel optimization scheme for assigning the data center to gaming requests that accounts for game requirement. Due to the high complexity of the optimization scheme, we designed an algorithm based on the online convex optimization method to drastically reduce the complexity of the problem such that it can be practically implemented in the data center, which using the open flow controller. The evaluation of the proposed method indicates that it can converge to the near optimal solution in the reasonable amount of time. And moreover, the experiment results showed that the proposed scheme on average outperformed existing algorithm by maximizing the bandwidth utilization and reducing the delay, and also at the same time achieving the fair resource allocation among the multiple competing gamers. Yeah, that's a short, I think, introduction of the paper, and I encourage people to watch the full presentation.
Okay, thank you. And the final paper in this slot is from Saman. He is a PhD student at Quality Usability Lab at TU Berlin. And he will give us a brief introduction about quality estimation models for gaming video streaming services using perceptual video quality dimensions.
Yeah, thanks, Christian, for the introduction. So in this paper, actually, we built a large-scale video dataset for gaming content. And the videos were encoded based on the typical settings that we use for cloud gaming service. So we use NVIDIA accelerator engines to encode the videos. We next evaluated several signal-based and parametric-based video quality metrics on this dataset and see how they work actually for gaming content. So at the end, we propose also two parametric-based models. So one for planning purposes, which can be used for network planners to, which they have some assumption about the network, and then one for monitoring purposes, which is based on the beta stream information that you can use. Yeah, so you can find also the model on my GitHub. So if you would like to test it by yourself, and of course, if you have any question, we'll be happy to answer them during the next session that we have. Thanks a lot.
Thank you. Now let's move on to the Q&A, and hopefully you can already see my other screen with the questions. Unfortunately, I cannot go into who's sharing this. Let me share my screen, please. Thank you. So we have here now a couple of questions, and we will have all questions here, and then let's move away this one here and start with the first question by Carsten, which is on paper 1, so which is actually for Mohammed. On the figure 12 in the paper shows Skype with repeating spikes. Isn't the spikiness in an effect of the averaging period? Is Skype special? Is that related to Skype's behavior of fast audio playback after it has been hanging for a while? Can someone please unmute Mohammed, Mariam, Said, and Saman? I think they should be all unmuted.
Yes, great. So actually, in that particular figure, this aggregation happens to the empty packets. So that kind of aggregation, we believe, happens at the server side. And for the other query that we wouldn't observe this kind of behavior when we were doing the experiments, but what we observed with other experiments, like we made a call and then call didn't reach other end because the network was off. But when the network was on, then the other end received missed call. So this kind of buffering probably could be responsible for such kind of Skype's behavior.
Good, thank you. Next question is for paper number 3, which is for Mariam, I think. Yes, I understand. It's questions coming from Thomas. I understand that the evaluations are conducted using Mininet, which has quite a very simplistic switch router model. How would a more realistic environment, for example, switches with limited QoS policies, affect your results?
Yeah, it's a great question. Yeah, it's right. The Mininet is like somehow quite simple switches and router, but it's emulator. So we couldn't find a chance to run the experiment on the real setup and like real router, open flow based router. But I don't think that it affects the result too much. So, but to be honest with you, we didn't try that, so I have no idea.
Okay, thank you. And since we have you here, the next question is also related to you and comes from Carsten, and then says that paper 2, I'm not sure now if this is for paper 3 or paper 2, says that different game types have different latency compensation requirements. Obviously, delay requirements differ. If you know this for every game, would you try to add a weighting factor when minimizing the sum of all delays? So I'm not sure. Is this for you, Mariam?
Yeah, that's for me.
Yeah,
That's completely right. Like different game has a different delay sensitivity, and in our formulation we consider that we add some coefficient, weight coefficient to our formulation to consider the weighting factor for different game in terms of the delay. Yeah, we already add this to formulation, and we also provided a table that shows the different weight based on the different delay sensitivity for different type of game. Yes.
Okay, good. Thank you. There's another question for paper 3, but also let's try to have some other for paper 2. We didn't have a question for paper 2, which is for Said. And the question comes for, where is it? From Shetil, about you have found that players play better in easier game. This does not compensate for delay unless the game is also equally enjoyable. Did you also ask, or do you plan to ask any questions about this?
Yeah. Thanks, Shetil, for the question. Yes, we had a subjective study and we asked for 12 questions regarding different aspects of gaming quality of experience. And we found that the overall gaming experience will increase when we are using the lag compensation technique. We are also planning to ask for more questions in future regarding like fairness, flow, and challenges. But regarding the second statement being equally the same as there was no delay at all, it's something else, and it wasn't the case for our study. and it's not even intended to be. Because in our previous study, we showed that if there is delay in there and you sense the delay, even if it doesn't really bothers your performance, it degrades your gaming experience. So to summarize my answer, yes, Gamel will have a better experience when we are using the lag compensation technique, but it's not going to be as enjoyable as when there is no delay.
Okay, thank you. We also like to have a question for paper number 4, which is for Saman. And could somebody please also unmute Saman? Okay, very good. Question is coming from Laura, and the model proposed in section 6 are only for passive viewing and listening tests. How much do you experts' results would change in a more interactive scenarios?
Yeah, thanks for the question. So that's a really good question. I mean, I'm not sure what was the part about the expert judgment. So, but in general, like maybe I can point out a few points. So, first of all, we have discussed and investigated that at ITUT Study Group 12, and we had long actually discussion about that. So, in short, if I want to say it, it is not recommended to use the proposed model for core gamers surely, because they are actually trained based on the passive data set. So there are many reasons that we don't want to have these core gamers to build such a data set. And the main reason is that their behavior is not constant. So it depends really on many user related features. So it could be the case that they don't like the game. They don't like let's say that some part of the game, they maybe lose the game, and it's so difficult to trace them. But when it comes to the casual gamers, so in our previous studies, we have seen that there is no significant difference between the result that you get from the passive test and from the interactive test if you select the stimulus properly. And we recommend to use that in the passive test, because then you expose all participants to the same stimulus and you don't get different types of stimulus to deal with that. So I hope that I answered the question as far as I understood.
Thank you very much. So let's move back to the number of upvotes. And this is again for paper number 3 for Mariam. Question is coming from Mia. In the formulated problem P3, isn't the objective F1 coupled with the objective F2? As when the bandwidth utilization is maximized, the average delay is expected to decrease. Another question, how is the fairness illustrated in P3?
Okay, yeah, that's right. Problem number 3 is a combine of 2 different objective. Objective function number 1, which try to minimize the delay, and the other one, if objective function 2, which is try to maximize the bandwidth utilization. That's why we converted the second objective to minimization. Then we have the compatible problem formulation. Another question is, how is the fairness illustrated okay, in terms of the fairness, because we didn't want to some games reach best performance in terms of the delay, got all the bandwidth. We have the constraint in the problem formulation in terms of the maximum tolerable delay. So that's how we somehow try to be fair to all the gamers in the problem formulation. Yeah, I hope it's answered your question.
Okay, very good. Thanks a lot. Next question is for paper number 2, which is from Said, and the question is coming from Pavel. So what do you think about implementing those compensation techniques in multiplayer games? In my opinion, some players may be favored than the others due to their poor network conditions or cloud infrastructure.
Yes, I also agree with you, but this paper was designed for single player games. And when it comes to multiplayer games, everything becomes different and difficult. You need to investigate the fairness. But the point about using this technique in multiplayer games is when you have delay already increases the challenges, and it's not fair. But when you use our technique, it's kinda can balance this challenge and can make it even more fair. But what I suggest is to use this technique with a matchmaking technique. So you can match the players with the same level of the delay into one lobby, and then you can apply this compensation. So in that case, it would be definitely be fair.
Okay, good. Thanks a lot. Then let's have another paper number 1 question, since I think we haven't heard from Mohammed since a while. So the question is coming from Laura. Do you have an intuition on how Facebook and Viber applications could improve in moderate or noisy environment?
Yeah. So these 2 applications basically use 2 specific codecs. One is called IPMR, and this other is called ISAC. And they are like not noise resilient. It means that they actually react to the surrounding noise, and their proportionality of this, affects this data actually severely. It means that more noise, more data exchange. So these 2 applications actually can follow like or use other codec. For example, this OPAS silk codec when it is in a noisier environment or something like that. Hope this answers the questions. Yeah.
Cool. Thank you very much. And then another question from Thomas on paper number 3. So it remains unclear how the controller-to-controller communication is implemented for me. And if you took control plane load into consideration, how does your proposed mechanism scale? Mariam, what do you think?
Yeah, we apply the hierarchical approach, which means that we have master, slave, SDN architecture. Like each data center itself has a master and a slave architecture, having their controller with 3 backup in our setup, and we can increase that to whatever data center we have. It's simple to be scalable. And also for the control plane just only make a decision which path we can we should be chosen between the data center. Like the main part is focused for the control plane, not the data plane.
Okay, good. Thank you very much. And we still have time for questions. And next one is coming from Mark and is for paper number 2. Said, what do you think? First of all, nice work. So in your paper, you choose constants, multiple target sizes by 2.5 to adjust the game word based on 200 milliseconds of latency. How would those constants be chosen in general? What do they depend upon?
Thank you, Mark, for your questions. Well, in this paper, we choose this amount by conducting some pre-test studies, and then we choose this amount by looking at the subjective ratings. But it might not be ideal for the real world. What we are planning to do is to use the decision tree that I presented yesterday and try to find the best strategy, like which characteristics that we need to change and how much we need to change. We are going to, in future, use the decision tree to find these amounts.
Good, and since I have you here, Said, I think there is another question from Mark for you related to your paper yesterday, where you proposed 9 characteristics, but the paper only uses 5 of these. What is the reasoning, thinking in your choice of these 5?
If we look at the remaining characteristics, they were more related to the user inputs characteristics, like what kind of input user is using, and we can't really change them in the game. For example, if the gamers is using a mouse, needs the mouse to control the game, we can't change them. It makes the game even more challenging for players.
Good. And the final question from Mark to you, Said. Many games allow the user to adjust the difficulty manually, easy, medium, hard. How can this manual approach be combined with your approach?
It's really interesting comment. But I think even if the game is already set to level easy, we can even go further and make it a bit easier. For example, we can increase the deadline, or we can reduce the precision, because there is always a room there. And in the other hand, if the game is too easy, it's already is low sensitive to delay.
Okay, and the final question goes to Mariam on paper number 3 and comes from Reza. Is it possible to define a backup controller in the first layer in your model? And is there any collaboration between the layer 2 controllers?
Oh yeah, we can define the backup in the layer 1, and it's in the its simplest form. The control play and provide the layer 2 with like MAC reachability, and with the layer 3 the routing, and yes, that's possible.
Okay, cool. Thank you very much for that. I think that concludes our Q&A for this very first online MMSys session on delay sensitive media. Thank you. So let me stop the sharing and let me, of course, invite everyone to thank and applaud all the speakers for coming here and for participating now in this, I think, kind of virtual panels setup where everyone could ask questions. We will bring back all these archived questions on Slido, and I invite all the authors to participate and to check questions related to their papers on Slido, and keep on the good spirit of discussion. And I think it's now time for me to hand over to the next session's chairs. I think Ali and Özge, floor is yours.
Yes, thank you, Christian. I think we have 1-2 minutes. I don't know whether people would like to have a very, very extremely short break, or if everybody...
Actually, let's continue, and then we take a break before the audio session.
Okay, perfect. So then let me go to...
So we have 2 sessions in this next 30 minutes. I will be dealing the first 3 papers, and Özge will be dealing with the remaining 3 papers. So use the common room for the Slido questions, and MMSys number 2 and number 3. And we can start with mine.
Here you go.
All right, we have 3 papers in this session. What's new in streaming? So the first one is a pretty nice work, a question that has been asked several times, especially among the streaming providers. In how do we pick the segment duration? Do we always use a constant segment duration? Do we need to vary it? What about the IDR frames, or what about scene changes and that sort of thing? So this paper is investigating that question in pretty detailed way. So Suzanne is with us. I believe she's able to speak.
Yep.
Could you make a short introduction for your paper?
Okay. Thanks first of all to you for the nice introduction. Yeah, what we had a look on was, can we use variable segments for adaptive streaming? So typically what we do is that we segment our video in equal duration chunks, for example, each 4 seconds. But as we need an iframe at the beginning of each of these segments, we have an additional encoding overhead introduced. And the idea was, which has also been, for example, proposed by Netflix as shot-based encoding, to align these segment split points with existing iframes, which are, for example, needed because we have scene cuts. And it is already known that this variable approach can reduce iframes. But what has not been known so far or not been extensively studied are the influence factors. And this was still missing. So this was the first major part of our work. We had a look on how much bitrate can we save and what are these influence factors. And the second major part was to evaluate how the variable approach impacts the adaptive streaming process itself. So what we have were a data set of more than 2,000 encoded video sequences, where we have evaluated this bitrate reduction. And we have more than 7,000 streaming measurements. And we found that especially in scenarios where we have a low bandwidth capacity, we can significantly enhance the QE. But we also saw that for high capacity scenarios that we might need to tune our adaptation heuristic.
All right, thank you. Okay, next paper. Hiba, who will be our organizer actually for the NT Women event tomorrow. She's from Telecom Paris, and she did this work with a dear friend of mine, Jean Lever, from also Telecom Paris, and our friends at Streamroot, which has been recently acquired. So that certainly shows the competence of this company and hopefully this paper as well. So, Hiba.
Our paper, we talk about extending the work of existing HTTP-based ABR algorithms to peer-to-peer networks. We address and analyze the main problems raised by integrating HTTP-based ABR algorithms with the prefetching-based peer-to-peer systems. And to enable the work of these algorithms, we present our approach called response delay, along with two different approaches to make these algorithms more efficient in the context of peer-to-peer networks, regardless of any ABR algorithm used. Additionally, we proposed two new metrics to quantify the peer-to-peer efficiency for ABR delivery over peer-to-peer. And we tested our methods using both simulation and real-life scenarios. And in our results, we show that we managed to enable the work of these algorithms in peer-to-peer with our two methodologies, one favoring the overall quality of experience and one favoring the peer-to-peer efficiency.
Okay, thank you very much, Hiba.
Thank you.
Okay, the last paper in this session is also, authors from Germany as well as Norway. And I believe Thomas Ziener will be presenting this. Thomas?
Thank you for the introduction, Ali. I'm happy to present the work of Teresa. Teresa was a joint PhD student or supervised by Anja Feldmann at TU Berlin, but is now with Netflix and not able to join the conference. So,
well, Thomas, I was thinking that I would get 3 female speakers in my session, but well, I guess I was lucky. I was hoping to get Teresa instead of you, but I guess we will just that's okay.
Yeah.
I mean, this could be the first ever all-female, MMSys session as well. So.
Our joint work is on getting or using informed access network selection to improve HTTP adaptive streaming. So the idea is mostly to use, if you have different access networks available, to use the appropriate one for a specific application. For that, we also have to touch it, the same problem, which was also introduced within the keynote. We need to align better applications and networks. And for the specific paper, this was done using a specific userland socket extension called socket intents, which allows applications to provide additional intents to the networking stack. And based on that, an intelligence or a smart algorithm within the networking stack is able to select the appropriate access network. So for instance, this algorithm also monitors the available bandwidth, figures out to which extent bandwidth is stable and which throughput is currently available, And then based on that and based on the intents he receives from the application, and then decides whether to go, for instance, to the cellular network or for a Wi-Fi network. So what we did also is we implemented this different policies. One of them, for instance, is honoring more a stable network connection, while another one tries to figure out when you have specific or very fast bandwidth or throughput drops, so outages, and then is able to switch to the other access network. And we did many evaluations in a controlled test environment using different traces, also from the Norwegian 3G, 4G traces, for instance. And also we evaluated different application and cross-traffic and how this affects the system. And based on our studies, we could show to which extent the proposed approach is able to improve the quality of experience, and also with respect to single network usage, and also with respect to multipath TCP, default scheduler, and in which specific scenarios other approaches are better. Thank you.
Great, thank
Okay.
you.
Thank you.
So let's move on to also the session 3 and also introduce the papers there. This session is all about mobile video, and we also have 3 papers in this session. So the first one is talking about power efficiency and considering mobile immersive video streaming. It is a joint work from University of Nebraska-Lincoln, SUNY Binghamton, Worcester Polytechnic Institute, and Adobe Research, and Rutgers University. And we have Nan with us to give a little bit more information on this paper.
Hi, thank you for the introduction. So in this paper, we proposed a method called Curate to reduce the power consumption in mobile VR video streaming with the minimum impact to the user experience. And to achieve this goal, we focus on the temporal domain of the VR video. Our idea is to reduce the frame rate of the VR view generation only when the user is quickly switched, given the fact that the user is constantly moving their heads during the playback. And during the movement, the view would be blurred anyway, so that the frame rate reduction will not be noticeable by the users. So in this paper, we demonstrate the significant power saving brought by the Curate using real power measurement on 5 smartphones with a commonly used HMD. And we also validate the minimum video quality impact using both objective and subjective metrics. So if you are interested in our work, please watch our paper and presentation, and feel free to raise any question during or after the live session. Thank you.
Thank you. So the next paper in this session is talking about whether we can basically time shift the prefetching of the videos in order to reduce the peak time cellular data usage. The paper is titled Untitled, and it is a paper from Georgia Institute of Technology, and we have Shruti with us to talk a little bit more about that.
Hi, thank you very much for the introduction. So our work is called Mantis. It's essentially a time-shifted prefetching strategy to ultimately reduce peak time cellular data usage. With YouTube currently dominating mobile data traffic, our focus is on YouTube content. What we aim to do is predict what content a user will watch in the next 24 hours, and then prefetch that content to the user's mobile device. So to this end, we collected a real-life data set consisting of 1.8 million YouTube videos. And then we developed an accurate prediction algorithm based on a k-nearest neighbor classifier approach, which attempts to prefetch videos after learning about the user's behavior and then predicting what they will watch and then prefetching that content. We also developed a proof of concept prototype and performed a user study. So for our data set, we saw that we were able to reduce the peak time cellular data traffic by 34% while increasing the overall usage by about 10%. Please feel free to ask questions during the session or afterwards. Thank you very much.
Thank you, Shruti. So the final paper in this session is also considering the energy. It basically talks about the energy considerations for the ABR video streaming for smartphones, to smartphones, and it considers the measurements, models, and insights. It's from University of Connecticut, AT&T Labs, and University of Minnesota Twin Cities. And I have Bing to talk about this paper.
Thank you, Oscar. Our paper is about energy considerations for ABR video streaming to smartphones, measurements, models, and insights. Video streaming is one of the most energy-consuming applications on mobile devices. There are a lot of studies on energy consumption in single-track video streaming. In contrast, little is known about energy consumption in multi-track ABR streaming. In our paper, we focus on ABR streaming, and we make three main contributions. The first, we develop component-wise models that estimate energy consumption of every component involved in ABR streaming in real time. Second, using these models, we quantify the energy breakdown of ABR streaming for both regular and 360 videos in both LTE and Wi-Fi networks. Last, based on the measurement insights, we exploit two energy reduction strategies for ABR streaming. Our results show that they can provide up to 30% energy reduction with little degradation in perceptual quality. Thank you.
Perfect. Thank you very much. Let me try to switch to Slido for our Q&A session. You can see the
yes.
Perfect.
Okay. All right. So the first question, this is for paper 1. Doesn't the longer segment duration lead to a less adaptive ability of the ABR algorithm? So the adaptation and granularity might change, obviously, with segment duration. So do variable segment durations also require the throughput estimation to estimate for a longer or shorter feature?
Susanna?
My speakers should be able to unmute themselves. Susanna?
Hello?
Yes. Okay, we can hear you.
Perfect. Seems to work now. A longer segment duration, yes, can lead to a less adaptive stream. If you imagine that you have, for example, a fixed duration of 5 seconds, and then you have a variable duration between 0 and 10 seconds, then you might have a segment which takes 10 seconds, and then the stream is indeed less adaptive. What I would like to highlight in this context is that we have used two different versions to compare the fixed and the variable approach. And in the first version, the average duration of the variable segments equals to the fixed segment durations. This is where we can have a less ability to adapt, meaning how fine granular we can do it. In the second method, we say that the variable segment durations are not allowed to exceed the fixed segment durations. This means if we use this method to compare, then if we have fixed segment durations of 5 seconds, then the variable approach allows to be between 0 and 5 seconds. And in this case, we can still save bitrate, but our adaptability of the stream is not limited. This is regarding the first one. The second one,
yes, so that's also for you. I'll take this question as well, and then we will rotate. Can you comment on the live latency? Oh, this is for the second paper, actually.
Second paper, yes.
Yeah, this is for Hiba. Let's continue with that one. Can you comment on the live latency when applying a peer-to-peer for video delivery during live streaming? So what's the typical live latency we are looking at?
Okay, so if you mean like in general about the live latency in peer-to-peer, I think it's already a challenge in peer-to-peer due to many facts. Like first, we have challenges for the peer-to-peer topology, like the peer matching, joining the session, and recovery after one peer leave the session, for example. And in a prefetching based peer-to-peer systems, this is even more challenging. Due to that, like in this prefetching systems, the segments are downloaded from other peers ahead of the time of the player request. And live streaming faces some problems since fewer segments can be prefetched in this case because they don't exist yet in the live scenarios. And if you are mentioning like why we didn't talk about live stream or the live latency in our paper, we mentioned that in the future work, we are planning to test response delay under low latency restrictions. But I think theoretically, we shouldn't have any problems since in the paper, we said that we don't touch the player at all. But we improve the behavior of the peer-to-peer to be as good as the CDN. So it will behave in the end as the latency of the CDN.
Yes, but then don't you think it's a bit interesting that a CDN company acquired Streamroot in the first place? So are they planning to amend their CDN offering with a peer-to-peer approach, or do you have any insight into that?
Of course, there are too many ideas and insights to work on that, and we already started, but we cannot disclose anything now. But yeah, like it's one of the biggest projects we are working on now.
Okay, thank you. The next question. Okay, any suggestions for the live broadcast where scene changes are usually a surprise? This is also for Susanna. This was my question.
Okay, yeah, depends a lot on how live in the end you try to be. I mean, if you decrease or if you increase the camera to display delay and go, for example, for something like 2 seconds delay, then you might still get a gain by using the variable approach. Otherwise, I'm actually not sure how good we can perform in live scenarios.
Okay, fair enough. And I will take a question for paper number 3. If you can bring that up, Özgü. All right. Yes, this is for Thomas. Do you think it will be beneficial to apply INS to other applications, and how? Does it make sense? And if it does, how do we do that?
In fact, we already started to do this, or we even had a previous paper on enhancing web page performance using IANS. And there was a look at the resources of a web page, decide whether you have a large or a small web resource, because if you have a small web resource, you might want to go for an interface which has a low end-to-end delay, because then TCP congestion algorithm ramps up faster, etc., and allows you to transmit more or faster a small resource as if you have a high bandwidth and a larger delay. So we did an evaluation on that, and of course for this we had to completely redesign an own policy. So it's something you should be aware of. To use something like IANS, you might have to think about a specific application, you might have to think about the requirements, and then you might have to think about how, then you have to think about how to implement a policy to take into consideration the important application requirements. So in our case, for the video streaming scenario, we had to do it in a completely different way, because there we were not interested in small resources or in distinguishing between small and large resources, and to improve the download time, but we're more also interested in investigating or to be supportive to the APR mechanism, because the APR mechanism decides which specific quality to download, and then within the networking stack, we decide which specific interface to use. So to be able, for instance, to either do it faster, or if we see that a bandwidth drop might occur due to some outage or something like that, then to switch to the other interface.
Okay, that makes sense.
Let me get a few questions from the session 3, if you don't mind, Ali.
Please.
So this is for Bing. So do you think your results are general enough, or having tests with more smartphones and maybe also more videos, network conditions would change the final conclusions? Bing Bang?
Okay, sorry. I'm just trying to mute myself. Yes, so I think so the paper has multiple contributions, right? So our methodology for deriving the models and our measurement methodologies are general. The specific measurement results are sort of for the two specific phones we are using. So when the phones change, when the hardware improves, then for other type of phones, the measurement results might be different. But on the other hand, we actually already see some interesting comparisons between the two phones that we use.
Okay, thank you. So this next one is for now, paper number 4. In the case of 360 video, the static case does display the whole panorama or only about one viewpoint?
So if I understand the question correctly, the static means the user is not switching their head. And in this case, we will not make any changes to the video, which means that the frame rate will not be reduced. And the whole frame will be processed and transmitted through the network. And only the user view will be rendered and displayed based on the user's head orientation. And like in this work, in this paper, we mainly focus on the temporal domain. So we only reduce the frame rate where the view is quickly switched. But I think it's also possible to further reduce the power consumption in this static case, where like only send the user's view so that the power consumed in the network part can be reduced. But this is highly depend on the like the view prediction algorithm. That is still a very open and a challenge research topic. But it will be interesting to combine these two.
Just along the same lines, can you comment on how frequent is the change of head that rapidly?
I think in the paper we mentioned it's video depending. So different video has different different video content that will cause the different user behavior. And so in some cases, some videos and some users will switch and their views quickly and around like 70% of the time. And that's some extreme case, but the average I will say is like 40–50% of the time that the user will quickly switch in their views.
Okay, thank you.
Thank you.
You want to take a few more questions? I have one for paper 5, which I would like to take. Do you think any learning algorithm such as reinforcement learning would be beneficial in prefetching?
Yes, I do think so, because ultimately what the prediction algorithm is attempting to do is trying to learn what the user has watched and trying to capture and encapsulate their behavior. So we hypothesize that a KNN approach would work better because you can kind of intuitively understand that there are clusters that users tend to kind of watch similar sort of items. And so a KNN would effectively is able to actually capture this pretty well. But I would take this into account, and I would like to explore how an RL algorithm would perform in the prediction. Thank you.
Thank you. Do you want to take a few more questions, Ali, maybe?
Well, let's see. Okay, we have time for one more question. Okay, so this is from, I would like to read Pavel's question. Are there any drawbacks of having variable segment durations? This is again for Susanna, obviously, and less iframes. So, I mean, once you increase the time between the iframes or IDR frames, obviously, you will be more error prone. So, I mean, is that a concern for you?
If we put it into the context of adaptive streaming, so we don't really have a drawback because of this fewer iframes. I mean, at scene cuts, we have them anyways. And this means we can still centrally encode the complete video. The only thing we were thinking about is that with each iframe, you also put, again, the complete image information, meaning it's also a refresher for the quality. However, we saw that the quality degradation we had is really negligible. So this was really a minor thing. So for that reason, I would say these fewer iframes are not a drawback with the variable segment durations. Regarding seeking, so if you want to seek somewhere to the video, you always have to load from the beginning of the segment. So what you might have is with the variable segments, again, this increased variability might lead that you have to load more data if you want to jump to a specific position in the video. However, on average, this should be the same because sometimes with the variable approach, you would need a fewer time frame between the segment start and the position you want to seek to, and sometimes it might be longer, but on average, it should be relatively similar.
Okay.
Perfect. Thank you so much, Suzanne, Hiba, and Thomas. So we are at the end of the second and third MMSys sessions. Now we will take a very short break, but we will be back for the open data set and data set session, as well as demo and industrial